Hello my dear students, I welcome you to NEET 1. So today we will be starting our 10th class chemistry syllabus here. Okay, the first chapter here we have is chemical reactions and equations here. So we are coming across many chemical reactions in our daily life, right? For example, when we keep an iron rod aside in the humid atmosphere, so it will get oxidized. The iron will be getting oxidized to iron oxide. So this is also an oxidation process which can be considered as a chemical reaction. So like this, there are many chemical reactions we will be coming across in our daily life. Like spoiling of food is also one chemical process only. Like that, it is very important for us to learn about chemical reactions. So how to write them in a theoretical manner here. So let us study all those things. So first of all, let us understand what a chemical reaction is. So chemical reaction is a process. A chemical reaction is a process in which one or more chemical substances will combine or will react to form some new compounds. Okay. So for example here A and B are two chemical substances, let us consider. So these will combine to form some product C or some product D. So like this, some reactant. So whatever the chemical species which are undergoing reaction are considered as reactants. What is this? These are called reactants and forming some new compounds which we can call them as products. So this side will be products. Okay, and the process can be represented with an arrow mark. So reactants are converting into product. Okay, fine. So now for this particular process, if we use any specified condition like a particular temperature or some heat is required, so we can represent on this arrow mark here or above or below here. So for example, if this process required some particular temperature, something like 273 Kelvin is required for this process, so we have to represent over here. Okay, and if particular pressure is also required, so we can represent here pressure. For example, 1 atmosphere pressure is required, so we can represent it like this. Okay, and see what I told, some chemical substances will combine to form products, right? So the combining substances are considered as reactants and the newly formed substances are called as products. I hope this is clear, right? Okay, so let us discuss little more about chemical reactions by understanding, by taking an activity base. Okay, so here let us do one activity here. So let us take one magnesium ribbon. Okay, magnesium ribbon you can take, and so take it with the help of a tongue. So this is called tongue. So use the tongue to hold the magnesium ribbon. Okay, so now first of all you have to rub that magnesium ribbon with some sandpaper so that it will remove whatever the oxide layers formed on that magnesium ribbon. So now we have rubbed magnesium ribbon, hold it with some tongue. Now take it to the Bunsen flame. So this is what the Bunsen flame we can say. Okay, so when we are keeping this, when we are exposing this ribbon with the flame, this Bunsen flame, so it will give us dazzling white flame. So what it will be? It will be burned with a dazzling white flame. Okay, so now there will be some ash or the powdered type product will be obtained here. So that is what? Magnesium oxide. So here I just collected that. I mean, here you can see, here we have collected something. So that is what? The white powdered form, which is magnesium oxide here. Okay, so what is that? Magnesium oxide. So in this process, what happened here we need to represent. So here magnesium ribbon. So magnesium we have taken here ribbon. So that is in solid in form. Yes. So magnesium here I have represented what is the physical state of this particular substance. It is solid. Then next, so for this combustion process, for this burning process, we require oxygen, right? So O2 here I have written. So O2 will be in gaseous form. Yes. So substance and respect to physical state, right? Then next. So give this arrow mark here, and we are heating it now, we are burning it now. So let us use the delta symbol so that represent we are heating this or we are burning here. Okay. Then next, so this will be forming magnesium oxide, MgO, magnesium oxide, which is in solid in form now. So you represent here S. S means solid. So this is how a chemical reaction is represented. Okay, so chemical reaction will be represented in this format. Okay, so here here I haven't represented with like this magnesium. So I haven't represented like magnesium like a theoretical symbol like word formation I haven't represented. So if we use these words like see chemical equation can be represented in two formats. One is word equation, another one is symbol equation. So if we use complete word instead of saying here magnesium, so here I just represented it completely like magnesium and the next oxygen and magnesium oxide. So these are called word equation. Okay, so this is what word equation. So it in chemistry when we are writing chemical equation it's better to represent in the symbolic form, symbol equation like see symbol equation we can represent, symbol equation we can represent. So for magnesium we can use Mg, okay, plus oxygen we can represent O2, okay, and write this arrow mark in order to show the reaction is moving forward and forming some product MgO, yes, okay. So like this. So this side, the left hand side of this arrow mark, so LHS side reactants will be written and the right hand side will be writing products. I hope this is clear. Okay, this is very basic here. Now here what I told you to represent their physical state. So magnesium ribbon I am saying now that will be solid. Okay, gas, oxygen will be in gaseous form and magnesium oxide will be in solid form. Like this we have to represent. So here heating condition. Okay, we are burning it now, so you use delta to represent heat. Okay, so this is how a chemical reaction is represented here. Okay, now check what are the elements present here. Magnesium, here also magnesium, here it is oxygen, here also oxygen, but how many oxygen atoms here we are seeing? So here it is 2 oxygen atoms or we can say 1 oxygen molecule. Here we have only magnesium attached with 1 oxygen. So magnesium oxide means 1 oxygen is present here. So number of oxygens LHS RHS side are not equal. So it means we need to balance this. So why do we need to balance? Let us look forward. Okay. So what are the things we have seen here? So first one is reactants presented left hand side of the like arrow mark, and for the right hand side we will be having products. Yes. The next reactants and products are separated by arrow mark. Yes. These are basic things that you should understand with full of clarity. Then next, if 2 or more reactants are present, how they got separated? So we have used the sign, plus sign is used. For example, A is a reactant and B is also reactant. So A and B separated with symbol plus here. So these 2 are combining to form some product C and product D I told you. So these are also separated with symbol plus. Yeah. So this is how we have to represent. The next condition should be mentioned on where. So I told you now condition should be like if any specific temperature is there, you can represent it on the arrow mark. Yes. The next physical state. Yeah, physical state of reactants and products to make the reaction more informative. Yeah. So we have to represent the physical state of reactants and products to give more information about this particular chemical reaction. So you can represent here at the bottom of their respective chemical substance. Yes. Then next, yeah. So what are the characteristics of a chemical reactions? So what do we mean by characteristics of a chemical reaction first? So the observable changes. So observable changes that are taking place during a chemical reaction. So for example, what are the observable chemical changes we will be seeing here? So we can see change in their physical state, or we can see change in the color, or we can see sometimes gases will be evolved. The next change in temperature also observed sometime, and the next formation of precipitator also takes place. So let us discuss one by one here. So sometime if a chemical reaction is taking place, some physical state may be changed. For example, combustion of fuels you can observe. So petrol will be in liquid in state, right? So everyone aware of this, I think so. Petrol will be in liquid in state. So when we are using it as a fuel, so by combustion of fuel, the engine will works. The bike or cars, whatever the vehicles we are using, that will be working, right? So now it will be releasing, it will be giving CO2 as a gas now. So whatever the fuels we are taking, that fuels upon combustion, like you can say hydrocarbons upon combustion produces CO2 gas plus water vapor will be released out, right? So petrol will be in liquid in state, here the products formed CO2 and water vapor will be in the gaseous form. So this is how you need to understand what exactly the physical state, change in state mean. Okay, so now here change in color. So what do we mean by change in color? So during some chemical reactions, reactants will be having some particular color and product will be having some other color. So for example, here if you look, so lead nitrate, PbNO3 twice, and potassium iodide, so these are colorless and which are in aqueous state. I mean aqueous we have written, it means they will be in liquid in state. Okay, the aqueous solution lead nitrate and potassium iodide are taken, so these are added, so it means these are reactants which are colorless. Okay, which are colorless. So when these are combined, we are getting lead iodide precipitate which is having yellow color. What color? Yellow color. So this is a precipitate, so it means solid in form. So you just check, look here, see, so lead iodide and potassium iodide are forming this kind of precipitate. See here, some yellow color substances settling down at the bottom of this like beaker, this conical flask. So in the conical flask, what we have, lead iodide and lead nitrate and potassium iodide are added, so that is forming a yellow color precipitate which is settling down over here. So this is what? Lead iodide. So this is how the color change may be also seen in the chemical reactions. Okay, so I hope this is also clear. So the next thing is, so what is the next we have here? We have evolution, evolution of gas. So it means, let us say calcium carbonate we have. So this calcium carbonate upon heating undergoes decomposition and forms calcium oxide plus CO2 gas is liberated. So which gas is liberated here? CO2 gas. So yes, so gas is evolved during this combustion decomposition process. CO2 gas is liberated. So calcium oxide will be in solid in form. This is also solid in state. Physical states are like this. Yes, I hope this is also clear. Next, change in temperature. Yeah. So this change in temperature we will be seeing in our daily life also. For example, take a piece of lime piece, take a lime piece and put it in the water, take a beaker with some water. So place the lime piece into that water. So we will be seeing some hotness. So we will be seeing some hotness to that beaker when we touch it. So why does that will be hot? Because the process, the chemical process, when we keep the lime piece in the water, it is evolving some heat, so that will be liberated out of that beaker. So it means whenever you are touching beaker, you will be feeling warm. Why it is? Because this is liberating the heat. So we can say that complete process as a exothermic process or exothermic reaction. So if heat is evolved from the reaction or from the system, we can say that is exothermic process. Okay. So what I am saying, exothermic process means during a chemical reaction, if heat is released, so that process is called exothermic process. Then next, during some chemical reactions, heat is observed. So what I am saying, during some chemical reaction, heat is observed. So those processes are called endothermic process. I hope this is clear. Then next, formation of precipitate. So here itself we have seen during this reaction, precipitate formation is taking place. See, in this reaction also precipitate formation is taking place along with the color change. So this is how the precipitate also formation takes place. Okay. Then next, let us move forward. So next, what are the physical states we have? So it can be gas, liquid and solid. So these are the physical states we have now. Now, when a solid is solid is converting into gas directly. So without converting into gas, liquid. So solid directly converting into gas. So that process is called sublimation. What is that? Sublimation. When a solid directly converts into gas, we can say that process as sublimation. So for this, the example we can consider is like camphor. So camphor directly converts into gaseous state. So we can say that process can be sublimation process. Okay. So now reverse of this sublimation, it means gas is converting into a solid. So we can say that is deposition. Okay. Similarly now, when a gas is converting into liquid, you can say condensation. When a liquid is converting into gas, we can say evaporation. So upon boiling the water, so water will convert into water vapor. That process we are saying evaporation. Now that is what? Liquid converting into gas is evaporation and reverse will be condensation. Right. Next. So liquid upon like when liquid converting into solid, we are saying that process is freezing, and the reverse is what? Melting. I hope this physical states, physical process is clear. Okay. The next, so balancing a chemical reaction. So initially I told you that when we are discussing about activity, there we have seen magnesium plus oxygen gas giving rise to magnesium oxide. So here we have only one oxygen atom, but here we have two oxygens, so which is not balanced. So during any chemical reaction, the number of atoms, the reactant side and the product side should be same. So here magnesium atoms are 1, here also it should be 1. Here magnesium atom, oxygen atoms are 2, here also it should be 2. So then we can say the reaction is balanced. So why it is means there is a something called law of conservation of mass. So what do we mean by law of conservation of mass? Mass can be neither be created nor be destroyed. What I am saying, mass can neither be created nor destroyed in a chemical process, but it can be transformed from one form to another form. Okay, what I am saying, it can be transformed from one form to another form. Therefore, the total mass of reactants should be equals to total mass of products formed. So you can write what is total, like law of conservation of mass means here the mass, the total mass of reactants should be equals to total mass of products. So here we can also say during a chemical reaction, the elements, see, the number of atoms of an element is same on the both sides of the arrow. So this is given from law of conservation of mass only. So here during a chemical reaction, the total atoms of particular element should be same for reactant side and the product side. So magnesium is fine here, 1 only, but oxygen is not balanced. So for that purpose, so instead of taking here it as 1, so we can take half mole itself, I mean half of this oxygen molecule, therefore it will be giving 1 oxygen. See, half means, so you can understand it like this, half into 2, so this will be nothing but 1 oxygen atom only, na? Right. So other ways, if you are still feeling confused, so I will tell you one more way to understand this. So you can write here, so magnesium, once again I am writing the same thing, and oxygen combining to form magnesium oxide, na? So here we have one oxygen molecule which is containing 2 oxygen atoms, so each molecule having 2 atoms, now, so here just multiply it with 2, here also you can multiply it with 2. Now just check here, 2 magnesium atoms, 2 magnesiums and 2 oxygen atoms here in a molecule and 2 oxygen atoms. So this is how the reaction is balanced. I hope this is clear. Okay. Similarly, can you give a try for this? Can you give a try for this basic one? So H2 plus O2 forms H2. So will you balance this equation? So formation of water from respective atoms, like molecules here, H2 and O2. So how can we balance here? 2 hydrogen atoms, here also 2 hydrogen atoms are fine, but oxygen atoms are 2 here in the molecule, but here only 1 oxygen atom. So what we can do? So whatever the thing we followed above, just give the same thing here also. So in order to do 2 oxygen atoms here, so we can multiply here with 2. Therefore we got 2 oxygen atoms, 4 hydrogen atoms. So it means if I multiply here also with 2, here we will be getting 4 hydrogen atoms. So this is how you need to balance the chemical reactions. So you can follow this is a hit and trial method. It means what is the number required, multiply with that number, so that the equation will be getting balanced. So give a try for this equation, methane plus O2. So methane upon combustion process, let us say it produces CO2 plus H2O, CO2 plus H2O. So will you try to balance this equation? So how many carbon atoms are there here? Yes, 1 carbon atom, here also 1 carbon atom, that is balanced. Now go for the next thing, how many hydrogen atoms are there? 4. So here we have only 2. So it means if I multiply with 2, what happens? 2 to the 4. Yes, that is also balanced. Now go for oxygen, here only 1 oxygen molecule is there, means 2 atoms are there. Here how many atoms are there? So here 2 and here 2. So total 4 oxygen atoms are there, the product side. So here we have only 2. So if I multiply with 2, 2 to the 4. So 4 oxygen atoms, yes, both side everything is balanced. So this is how we need to balance the atoms of a particular element in a given chemical reaction. Okay, so I just want to give this as a homework. So give a try for this. C2 H6 plus O2 gives rise to CO2 plus H2O. So will you give a try for this to balance? How can we balance this? So let us say here the number, see, while balancing this reaction we got the number 2 here now. So I just indicate here X. So tell me the value of this X in the comment box. Here I am representing the value as Y. So tell me what is the value of Y, and also here it is Z. So values of X, Y and Z. Tell me. In the comment box you just mention X, Y, Z values. Then next, so this is what we discussed, law of conservation of mass. Then next, so let us take one generalized equation. So we know these are carbon. See, in a given compound we have only carbon and hydrogen. We can say that compound as hydrocarbon. What is that? Hydrocarbon. Okay, so in a given compound only carbon and hydrogen is present, we can say that is hydrocarbon. So we know hydrocarbons are used as a fuels. Mostly they will be having fuel application due to their high calorific value. So what is this calorific value? We will learn later. So due to their high calorific value they will be used as fuels. So now let us say this is one hydrocarbon. So we are burning it. Upon complete combustion of this hydrocarbon, we will be getting CO2 gas and H2O, right? So will you try to balance this equation? So how many carbons are there? X number of carbon atoms are there. So complete carbon should convert into CO2 gas now. So it means we will be getting X CO2 molecules. Then how many hydrogens are there? Y number of hydrogens are there. All hydrogens are converting into water. So I am writing here Y. See here already 2 is there. So if I write like this, it will become 2Y. But here we require only 1Y now. So just take it as Y by 2. I hope this is also clear. Then next, now carbon, hydrogen is balanced. The remaining thing has to be balanced is oxygen. So here we have how many oxygen atoms? 2x. Here 2x oxygen atoms are there. Here Y by 2 oxygen atoms are there. These are atoms, right? This many number of atoms are there. But if I multiply here this with the same number, it will become double because it is molecule. So what I am doing is 2x plus Y by 2 all by 2 number of O2 molecules are there. Here I will be writing like this. So that this will become x plus Y by 4. So here what do we need to write here? So here we need to write as x plus Y by 4. This many number of O2 molecules will be there. So you can balance the equation like this. Okay. So now you can try that whatever the example question, homework question I given. So you can try using this generalized equation also. I hope our discussion is very helpful for you. So keep watching our channel for more videos on chemical reactions and the equation and also other chapters of this 10th standard. Okay. So thank you for watching. Happy learning.